Hello guys, and here we are in Pixinsight, and I'm going to show you how I go about stacking using the weighted batch pre-processing script. So the weighted batch pre-processing script can be found in Pixinsight under scripts, batch processing, weighted batch pre-processing. So let's go ahead and open that up. Now, before I go ahead with this, I would usually have already checked all of my images using Blink to make sure that I've got right exposures, and I kind of remove and get rid of any images which are out of focus. I've got stars trailing, cloud cover, etc. So once you've done that and you're happy that you're starting with a good set of data, you can go into the weighted batch pre-processing script, and we can throw into here all of our data if we've been imaging over multiple nights, which I have been for the Rosette nebulae. So let's go into our Rosette Nebula here, and I'm going to load up all of the lights that I have. So these are 300-second exposures, and then I also have some 120-second exposures, and I also have some 150-second exposures. So we'll open up all of those, and then we need the darks that match these. So you can see it's already separated them up for us. 300-second exposures, 150 and 120-second exposures. Now we will add in our dark frame. So we go to add darks here, and we'll load up the darks that we have for those different exposure lengths. So these are our 300-second exposures. I have darks for the 150-second exposures. Yeah, 150. 150, not 180, sorry. Now there's our 120. And our darks for the 150 still. There we are. Now 150 darks. Okay, so there we have our dark frames for the 300, the 150, and the 120. Same as what we have, 300, 150, and 120, okay? And then the last thing I'm going to add in will be our bias. Okay, so now we're done with that. I'm going to go over to our calibration here, and we select this, and I'm going to check the optimized master dark. You'll see now that will use our biases to create that optimized master dark. If we don't do that, then the bias isn't going to be used. I don't have any flats. Cosmetic correction, if you want to apply this, I'm not going to. So we'll just leave all that as it is. Now in our pipeline here, I'm going to check linear defect correction, just in case there are any. At the end, we're going to do image integration. So that will integrate the master light frames will be generated. Okay. So now I've done that. Quite happy with everything here. I'm going to make sure that I am doing the maximum quality with no compromises, and an output directory. So this is going to be the Rosette Nebulae. Just going to create a directory for this. So that's where all of our files are going to go out to. Now, Once we are done with this, so basically we've thrown everything into here, you'll see it separated up for us nicely. Does this work for us? The 150 to 300 to 120 seconds. If you're shooting over multiple nights with different exposures, this can handle all that for you. So there's all of our lights, and we're good to go now. So all we're going to do is hit run. Now this will take up to 40 minutes or so, depending on how many images you actually are integrating here. So I'm going to hit run, and I'm going to pause the video, and we'll come back when this is finished. Okay, so you can see this script took 24 minutes to execute. I didn't have a huge number of images, so it didn't take too long. I've seen it take up to 40 plus minutes. You can see how many were rejected, how many measured, how many were used. So pretty much all have been used almost. So that's pretty good. So now the weighted batch pre-processing script has completed. You see here it gives you a log. You can always go back and look at what it did and what the results were. But I'm pretty good with everything. That all executed well. So now I'm going to move on to the next part of my stacking process, which is under processes. I'm going to use the subframe selector. Now, this is kind of similar to what Blink does, but with Blink you're going to do it manually. So with Blink you will go through all of your images, and kind of visually you're going to choose the ones which have eggy shaped stars, have maybe some satellites trailing in them, whatever it is, whatever defects, you're going to remove them. So I do that before I do the weighted batch pre-processing. Now after, I will still run this subframe selector just to get rid of maybe some more that I might have missed. So we're going to measure subframes, we're going to add files, and we'll go to the folder that our weighted batch pre-processing script just outputted to. So here we've got our calibrated images, debayed images, our registered images, and our master lights and so on. So we're going to use the registered images basically. So we've also got these, we've got this calibrated here, but we're going to use the registered. Okay. So I'm going to open up all of the images that we have there. So because I've got 3 different exposures, it's outputted for us, the weighted batch pre-processing script has outputted into 3 separate folders for these different exposures. So I'm just going to open them all here in one go. Okay, and I'm going to measure the subframes. I'm also going to change my output directory here, and I'm going to make a new folder called weighted. That's where they're going to output to. We're not going to output yet. All we're going to do first of all is measure the subframes. So we'll go ahead and run this. That's going to run through all of our images and measure them and give them a kind of score. So we're going to see a graph, and it's going to show us how it's scoring on that graph, and we're going to be able to select the images that are not scoring very well and kind of eliminate those from our final weighted folder, which is going to put all of the images all together in that one folder. Okay, so I'm going to start off by looking at our FWHM, and I'm going to select the images which are just sticking out here, which are kind of the outliers. Okay, so we'll get rid of those 2. Eccentricity, I'm going to get rid of those 2. And on our stars, I want to get rid of the ones which are not having a lot of stars. So I'm going to get rid of that one there. Okay. Now here I've got a weighting formula. I'll put that in the description of the video down below. That's what creates this graph, the dotted line graph that you see there. Okay, so we've now excluded the images that we want to. We'll go to now output subframes. It's going to output to that folder. Our keyword will be SSWeight, subframe select the weights. Okay, so we'll run this. That now is going to output the images to our weighted folder minus the ones that we have chosen to exclude. Now we are done with that. We'll go over to our image integration. So all processes, image integration, and we're going to choose all of those weighted files that we just outputted from subframe selector. We're going to combine them using a fits keyword, which we used was SSWeight. Pixel rejection, we'll leave that on here on the default. Signal to noise evaluation. You can choose whether you want to do large scale pixel rejection. I don't, I leave that unchecked. And now we will just run this. So that now is going to go through all of those images that we have, and it's going to integrate them together into one final stacked output. So I'll just pause the video and we'll come back when that's done. Okay, so the image integration is done, and there's our rejected ones. We can close that. We can close this. We can close our image integration. So there we have it, our finished integrated image. Doesn't look that interesting right now, right? Okay, so here is what we will do next. We're going to apply a screen transfer function stretch, and that gives us an initial stretch and shows us what we've got here. Now you can see this green color we don't really like. So this now is kind of beyond the scope of the original title of this video, which was how to use the weighted batch pre-processing script. But as we've got this far, let's go on and show the rest of the process. So what I'm going to use first of all is my background neutralization, and that will get rid of that green color. So we'll apply another stretch. Now we want to get rid of the gradient. Pixinsight has a new tool that gets rid of gradients, but before I do that, I'm going to crop the image. So I'm going to open up our crop there, and we'll just crop off the edge here, because usually there will be some artifacts around the edge from the kind of alignment and stacking process. So we'll get rid of those, and then we will use this new tool from Pixinsight, the latest version, which is the Pixinsight gradient correction. Now I used to use a script called Gradient Expert, no longer need that. I'm just going to use this, and I drag and drop that onto there. It'll run, and it will correct some of the gradient issues that we may have in the background of this image. So that's helped us out with that. There we go. So now, next thing we're going to do is run a paid plugin, which is Blur Exterminator from RC Astro. That will just help us sharpen up some of the stars here. So a few of the stars, it'll just tighten them up a little bit, remove some of the halos. Our stars were already pretty good in this image, actually. Our tracking was quite good. You can see here, let's just zoom in on them, do a little bit of pixel peeping here. So we'll do before and after. So that's before the RC Astro, Blur Exterminator, and that's the after. So you can see it just tightens up the stars a little bit, if you like those tight pinpoint stars, which I do in my images, especially on this, where I really want to be focusing mostly on the nebulae and not so much on the stars. Okay, so now we're done with that. We're going to use the noise exterminator. This can be a little overzealous, So I'm going to knock it down to about 30, and we'll run that. So I'll run it zoomed in here so you can see the difference it makes. Okay, so let's focus, say, on this region here. So here's a before and after. This before, you can see a lot of this noise that we've got around there, and this is after. Just help to tame a little bit of that noise. Okay, and then finally, another RC Astro paid plugin is Star Exterminator. I don't want to delete the stars completely. I want to generate a star image, unscreen the stars, and we're going to add the stars back in later. But I don't want the stars here while I stretch the image. So we can remove them. Now, actually, before I do that, I want to apply a photometric color calibration. Now, what this will do is it will use a catalog of the stars that we have here and apply a color calibration based on what we know the color of those stars should actually be. So we'll drag and drop that across. Now, it's probably going to fail because it's going to say there is no valid astromeric solution. So what we're going to do first of all is run a script here, image analysis, and we are going to do an image solver. This will basically plate solve the image for us, and hopefully it will be able to establish what part of the sky this is an image of, and that will then allow us to use a photometric color calibration. So this is going to basically plate solve the image. So those of you familiar with that, it basically looks at the stars and it will try and find a pattern in the stars so it knows which part of the sky this is an image of. Once it knows which part of the sky it's an image of, the photometric color calibration will go up to a database of stars that it knows are in this image. Once it's done that, it then will download the RGB values for those stars based on what scientists know the colors of those stars should be. So that's successfully solved. We can now use the photometric color calibration. It should be successful this time. So it's going up now to the database, it's extracting these signals, and it's applying now the color calibration to this. It gives us this little output. I don't really know what that means, so I'll just skip over it. But what I do know is now we have a color calibrated image. So you can see here, let's take a look at the before. That's the before, and here is the after. Let's apply the stretch. Okay, so now we've got a more realistic color to this image based on the actual RGB values. Okay, so now we've done that. Now I will run the Star Exterminator, generate a star image, unscreen the stars. We'll run this. That's going to strip all of the stars out of this image and put them onto a separate image for us, which allows us to then edit the nebulae only without affecting the stars, ending up with star bloat, etc. So we'll just minimize that star image for now. And here we have our image. Now you can see the amp glow here. That should have been removed really by our calibration frames, but it hasn't. That's possibly because I was a bit lazy with shooting the darks, and I didn't shoot them, and I took some from another night on different images, maybe a slightly different camera rotation. So this has not been removed. However, I think that we can get rid of this using a clone stamp tool. Let me see if we have that in here. There is a clone stamp tool somewhere. Clone stamp tool there. Okay, so we'll try this. I haven't used this before. I usually do this part in Photoshop, but we'll try it. Please select the valid source point, command and click. Okay, so we're going to select our source point, which will be over here. Let's make the radius bigger. Let's go to about 20 pixels for this. So you can see now we're able to kind of paint out that amp glow that we've got there. So this isn't ideal. Ideally, this would have been removed by our calibration process, but it's a little workaround as it wasn't. It's not going to be perfect, but it will help us a little bit. We're just tidying up and getting rid of that amp glow. Okay, now it's gone. Good with that. That helps us out a little bit. Now we will move on to, let's remove the screen transfer function. And I'm going to go to something called the generalized hyperbolic stretch. We'll open up a preview. I'm going to start off, first of all, with a linear type. I don't need to do much, actually. We just move that across until we just start seeing clipping. So it's a very tiny amount that we need to move this. We don't want to do any low clipping, so that's basically done. So our black point is kind of set. Now, generalized hyperbolic stretch, we'll click somewhere around the middle, little to the right of this here on the histogram, which is the overlapping RGB data where you see it in gray. Send that to the set point. Now we can adjust our stretch factor here until we start to see that nebulosity coming out. Now we don't want to go too far. We can use the local intensity to decrease the local intensity in some areas. And obviously we don't want to begin to blow this out too much. So I'm just going to bring it this far here and we'll apply that. Reset. I'm going to click over to the right a little bit there, send that to set point, and we'll drag out again. This will bring out some of the darker areas a little bit. We'll apply that. Again, I'll reset. I'm going to click over to the right of that gray area, stretch a little more, not too much, I don't want to blow these out, and that's good. Okay, so there we go. It's starting to look quite nice already. There's still more we can do. I'm going to open up the curves transformation. So I'll select our red here. Now there's a lot of red in this image. So how much of that we want to bring out is up to us. Now I don't like to oversaturate things. It starts to look a bit phony to me. But we'll bring out a little bit of that red there at the top. We'll decrease it down, lower down. So just play around with these curves. Now this is where the kind of art comes in. It comes down to personal taste as to how much of this you want to bring out. Obviously the more red I have, the more red that's going to be, but I can pull back the red at the highlights if I want. Now we'll go over to our green and we'll adjust our green. So I want to have a little bit of green in this at the higher end, but not so much at the low end. I don't want that background to be green. I want to keep that background dark, so we'll pull it down a little bit at the bottom there, but I do want to increase it in a few other places just to add a little bit of interest to this. I don't want the image to be too red. I think that looks kind of boring if we have too much red in there. Okay, and then we'll do the same with our blue. We'll bring out some of the blues, but decrease them there at the lower end. Not too much. Okay. Now I can go over to my saturation and we can play around with our saturation curve here. And then also our hue, if you want to change the hue any. So you have to be careful with this. I do want to bring out a little bit of that green though, but not too much of it. Okay, so once you're happy with that, we'll go ahead and apply it. And now under processes and image transformations, I'm going to go to color saturation here. Open up a preview. Zoom out. Okay, hold on, let me reset this. Okay, so now we can play around with this curve to get the amount of saturation we want at different levels here. Now you can see we've got some noise starting to come out at the back there because we're starting to oversaturate the image a little bit, and it's bringing out some of that noise. So I'm going to dial back some of this saturation, and some of that may have also come from the stretching that we did as well. So we'll apply that. I'm going to go back to my generalized hyperbolic stretch. Oops. We'll reset this. We go to a linear transformation, and I want to try and bring that background darkness in a little bit. So we are going to start clipping some of those low pixels a little bit here. Not ideal, but that's okay. You know, once you start clipping, you are actually removing some data, but that's okay. Still looks okay to me. I'm going to go with that. And then our curves transformation again. And at the red here, I'm going to bring that back a little. And at the green, particularly at the lower end here, try and get rid of some of that green noise that we had in the background there. But at this higher end, I'll bring it back up. And the same then for the blue. Get rid of some of that low end blue noise, but maintain the blue here at this higher end there without overdoing it. Okay, we'll apply that. And now finally, for this, I'm going to go ahead and apply a unsharp mask. We'll preview this. So how much we want to sharpen the image. We can play around with that here. More sharpening we do, the more noise you're going to introduce. And we can change the amount. So, you know, obviously if I make this too much, we start introducing an awful lot of noise there. So you have to be careful with your sharpening. It's a balance between noise and sharpness. Obviously, if we don't do any sharpening, we get this quite soft image, which is okay, but I would like to just sharpen up some of this detail a little bit. Okay, so you can see with and without the sharpening. So I'm going to go ahead now and apply this. Close down our preview, and there is our integrated image. You can see before sharpening and after. It just brings out some of those filaments a little bit, sharpens them up. Okay. It has introduced a little bit of the noise in the background there again, so we can go back to our curves transformation. We can try and reduce that. And same with the green. So the same as we did before. Decrease at the lower end and up at the higher end there. Okay, so now I'm happy with that. We're going to put our stars back in. So we're going to use pixel math for this. But before we do that, we should also stretch stars. So currently the stars are linear. We'll open up our generalized hyperbolic stretch again. We're going to apply it to the stars layer this time. We'll drag that across until we get as much of the stars as we want. Now I don't want too much of the stars, so I'm just going to bring that not too high, obviously. Somewhere around here is good for me. We'll apply that. So there's our stretched stars, and we now want to add those stars back into our image here. So we'll go to image processes, and we're going to go to pixel math. Pixel math will add these two together. So our image is called integration and integration stars. We're going to add those together. We'll run this, and there we go. Now we have our integrated image with the stars. Voila. Okay, so basically we've been able to edit this image, stack it, edit it, process it in, well, this video is running 31 minutes. Okay, the stacking process took around 30 minutes, so let's say an hour of work, and we've been able to produce a pretty reasonable image here. I'm quite happy with it. It could have more work done to it, of course. There is more this could be done to this. There's more advanced editing techniques, but as a kind of basic processing of our data, this is not bad at all. So I hope you found this video useful. If you did, don't forget to like and subscribe to the channel, and you can always head over to my blog. That's nixastrophotography.com. Link is in the video description below, where you can see the work that I'm doing and these videos and tutorials. So thanks for tuning in, and I'll see you in our next video.